So resistance of the galvanometer is Vg by Ig. So how do we convert galvanometer into an ammeter? A small resistance called shunt resistance has to be connected in parallel with it. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. In this session of discussion, I will be solving numericals from the next model question paper. The first problem, an interesting problem from the concept of interference. In Young's double slit experiment, a source of light of wavelength 4200 angstrom is used to get fringes of width 0.06 meter. So we are getting a fringe width of 0.006 meter when light of wavelength 4200 angstrom is used. I have to calculate the wavelength of light of another source to get fringes 0.0045 meter. In order to get fringes of width 0.0045 meter, what should be the wavelength of light used under the condition distance between the screen and the slits is reduced to half the value? So here we have two cases. So in the first case, now how do I equate or relate fringe width with the wavelength of light used? We know that beta is equal to lambda d divided by d, where capital D is the distance between the slits and the screen, and small d is the distance between the slits. Now the problem says, in the first case, wavelength of light used is 4200 angstrom and fringe width is 0.006 meter. So we have 0.006 is 4200 into 10 power minus 10 into capital D divided by small d. I call this equation 1. In the second case, we are getting fringes of width 0.0045 meter. So again here 0.0045 equals, I have to calculate lambda. Now the distance between the slits and the screen is reduced to half of the initial value. So this capital D becomes D by 2 divided by small d. I call this equation 2. So we have to find the value of lambda. So now what we do is, I will divide equation 2 by equation 1. The simplification is left to you all. It is a simple division where lambda turns out to be 6,300 angstrom. So such problems, very simple to score. Just know the relation, you are arriving at the answer. The next one, students. Two coils, two resistor coils have an effective resistance of 16 ohms when they are connected in series, and 3.75 ohms when they are connected in parallel. So first, the two resistance coils are connected in series. They have an effective resistance of 16 ohms. Then they are connected in parallel. Now they have a resistance of 3.75 ohms. I have to calculate the individual resistances. Now, first the problem says the two resistors are connected in series. So when they are connected in series, what is the effective resistance? So RS equals R1 plus R2. And according to the problem, when they are connected in series, the effective resistance is 16 ohms. So we have R1 plus R2 is 16 effective resistance when connected in series. Next, they are connected in parallel, where we know RP is R1 R2 divided by R1 plus R2. So when they are connected in parallel, effective resistance is 3.75 ohms. So 3.75 is R1 R2 divided by R1 plus R2 is given, which is 16. So R1 R2 is equal to 60. Now, I will use the equation of biquadratics where R1 minus R2 whole square equals R1 plus R2 whole square minus 4 R1 R2. Now on substitution, this is 16 whole square minus 4 into 60. So on simplification, R1 minus R2 is equal to 4. Now I have R1 plus R2, which is 16. R1 minus R2, which is 4. Now solving these simultaneous equations, R1 plus R2 is 16. R1 minus R2 is 4. So 2 times R1 is 12. So R1 is 6 ohms. Now substitute R1 in any one of the equation. You get R2, which I expect you all to solve. The next problem, students. The problem says, it is required to convert a galvanometer of current range. So current range is given to be 0 to 15 milliamps and voltage range 0 to 750 millivolts. So the current range is 0 to 15 milliamps and voltage range is 0 to 750 millivolts. First I have to convert it into an ammeter of range 0 to 25 amps and next voltmeter of range 0 to 150 volts. I have to calculate the value of respective resistances and also I have to explain how they are connected. So the problem says the current range IG is 15 milliamps, which is 0.015 ampere, and the voltage range is 750 millivolts, which is 0.75 volts. With this, can I calculate the resistance of the galvanometer? Resistance is V by I. So resistance of the galvanometer is Vg by Ig, 0.75 by 0.015, which is 50 ohms. Now what is that I have to calculate? First, I have to convert this galvanometer into an ammeter whose range is 25 amps. So, in the first case, I am converting it into an ammeter where I is 25 amps. So how do we convert galvanometer into an ammeter? A small resistance called shunt resistance has to be connected in parallel with it. So, expression for shunt, S is Ig into G divided by I minus Ig. Or this is, what is Ig? 0.015 into 50, 25 minus 0.015, which is equal to 0.03 ohms, which means I can convert that galvanometer into an ammeter by connecting a very small resistance of 0.03 ohms in parallel with it. Next, I have to convert it into an voltmeter of range, which is 150 volts. So now I have to convert this into an voltmeter whose range is 150 volts. So how do we convert galvanometer into voltmeter? Connecting a high resistance in series with it. What is the expression for that high resistance? R equals V by Ig minus G, or R equals V is 150, 0.015 minus 50. So on simplification, this is 95 ohms. So this is the high resistance which has to be connected in series. We have to find the energy of the neutron having de Broglie wavelength 10 power minus 14 meter. And given the rest mass of neutron is 1.67 into 10 power minus 27 kg. We know that de Broglie wavelength lambda is h divided by mv, where m into v is the momentum of the neutron, from which first I will calculate the velocity of the neutron, which is h divided by m into lambda. So velocity is 6.625 into 10 power minus 34. The mass of the neutron is given, which is 1.67 into 10 power minus 27, and the de Broglie wavelength is 10 power minus 14. So on simplification, this is 3.9 into 10 power 7 meter per second. With this, we will have to find the kinetic energy. So what is the expression for kinetic energy? We know lambda equals h divided by root of 2MEK, or lambda square is h square divided by 2MEK. So on substituting and simplification, here EK is nearly 8 MeV, which the simplification is an assignment for you all. So students, in this particular session, I have solved model question paper. My next session, I'll come up with few more problems. Until then, have a nice time. Thank you.